and final part of the basic course for PLC and for PLC modular from Mitsubishi Electric. In this part, we will see the main programming objects of a program. We will start from the creation of the blocks, a program already partly seen in the final part of the second part of the course. We will see below how we can create and space function blocks, how we can create and recall a function, or how we can add, integrate into our project. For example, structured data, data types, and so on. We will show how to compile the code, how to establish a connection with your PC in order to then download the project PLC, which physically, in my case, I will be connected, therefore, an R04 CPU. We will then see the main code debugging tools that are often used during the startup of testing phase of the application. Among these, I mentioned the simulator integrated into GXWorks 3, which allows you to virtualize the PLC on your PC. Therefore, being able to debug your program even before physically interfacing with the PLC. Finally, we will talk about the manual viewer, which is a complete integrated manual tool, clearly in digital format relating to iQ-R and more. We have already partially seen, as we said in the second part of the course, how to create a block or a program. Let's quickly repeat the steps. Above all, we will quickly create a new GXWorks project again, GXWorks 3. And for this project, we will define our R04 CPU as the hardware configuration, plus because then once the code has been compiled, we will download it, then write it to the PLC. But in my case, I am interfaced to a rack with the sole presence of the R04 and therefore the CPU. So let's exclude the modules that we had previously added in an example hardware configuration. Again, I choose an R04 and I'm going to create the first program file, so the first program block in FBD. Okay, let's start into hardware configuration. I choose my slot my slot 5, my 5 slot. I drag the CPU inside the rack, and now let's select our power supply. So we must go to power supply and choose R62P. There is my system configuration. We are good with the hardware configuration. As regards the program block, instead, as also seen in the second part, we already have one by default. Let's go and rename. In this case, we can rename this Automatico. Maybe we give it automatic name, as in establishing that here we will take care of managing all the logic. As already the effect perhaps the automatic cycle of our machine. And now moving on with the presentation, and so we are reminded of the steps to create a new program block. I also remind you how it is possible to determine the execution order of the program blocks when in our automatic general file we perhaps determine more program blocks, more program containers. We could establish the execution order, then choose the priority of one over than other, then right-click on the program file setting, and we will determine at the program block level what the execution order is among themselves. As far as editing is concerned, we can proceed in different ways to edit the code. Therefore, as regards the basic instruction, here we are referring to the FBD. Certainly applies to the letter. The use of the toolbar tool. So here is the toolbar where the elements are shown. Therefore, coil contacts, possibility of adding comments in the code. In addition to this, so to speak, you can resort to shortcut rates, positioning yourself directly on the worksheet. So we are inside our program editor at any point. For example, typing the shortcut F5, let's go to add a normally open contact. This is useful too, and you can also use the menu bar at the top in the development environment. So edit, edit an element. Here too we are presented with the elementary objects. Here, for example, in FBD or in ladder. As for the other instructions, I use the element selection menu. So we find, we have already partly seen and known it. We find an element selection window on the right. Here, when from the moment we open a programming editor, we see a list of all the integrated system functions, the integrated system blocks. We could come here, choose ours, and drag and drop. Drag it inside the editor, even better since we know what we need to add. So what function should we use? Editing the code directly from the keyboard, positioning yourself in the worksheet. This is our editor. Right now on the right we have the element selection perfectly in poll list. So let's go back to the poll list. Here we find all the programming elements already integrated into the system, divided by topics. I could come here and use the Finder to locate exactly what we are interested in. But even better, we can place ourselves in a point of editor. In our case, we want to we want to do a transfer between a 16-bit source and destination. As a source, we directly pass as its title, for example, a small number, in order to write a number like this, since it could mean expressing it with the H in hexadecimal format. As a destination, instead, in this case, we can choose the one user device. It may be useful to use the instruction with. Therefore, as in our case, we have added a move. I could select the block and go to the question mark. It would send us back to help and then to the manual viewer. Otherwise, the same goes by pressing F1. This clearly can be useful, especially when dealing with code written by perhaps someone else, therefore to be able to better interpret it. Where there are functions that we don't know, we can use the link with the manual viewer. This applies to all functions. Okay, so it gives us detail on the types of data required, on the working range, description precisely of, in this case, of the source of the destination. Still on the subject of editing, by editing the code in FBD or ladder, it's possible to use the label creation tool more quickly. I write from the keyboard to the label I want to create. A label editing pop-up will automatically open where I define the label type, optional comment type, and at the end confirm with OK. Here I'm going to open my Gixworks 3. And for example, let's go to add a contact. And for example, I want to use a local label. So I double press and now I call a generic memory. So now I must define some information. For example, in this case, the name, the fact that is a local label, the local or global. In this case, we select local label, the class, so the var class, and the data type. In this case, we can leave a bit. So after that, we can press OK. And now we can go to the local label part and we will find our new label registered. So once registered, clearly, if we now go and type and go look for it to reuse in a second part of the program, he now identifies it and therefore proposes it to us. Okay, let's talk about functions. Functions are called from program blocks of function blocks from other functions. A function returns a result upon execution of its call, called return value. A function always returns the same return value when processing the same input values. The variables defined in the function and overwritten each time the function is called. In fact, the main concept that distinguishes a function from a function block is that the function has no memory. This means that, for example, if we use the function, for example, to process data within which, however, in our function there are internal variables at each execution of this function, this variable will not maintain the value. For example, that it had in the loop previous PLC. This great aspect is what substantially differentiates the function from the function block, most of all. So, for example, for a function, it makes no sense to be able to hypothesize writing a function within which there is a machine states, because there would be no way to keep track of the state maintained in the previous PLC cycle. As mentioned a little in the second part of the course, you go to the project 3. In the FB fun add new data section, you go to identify function. As the data type, you choose the name of the function, and the result type, you choose a data type which will be returned by the function, the type of data. In this case, where we will hypothesize a function for the calculation of an area of a triangle, we will choose type float as the result. Therefore, we will work with real values. Okay, let's go to FBFun, choose the function, and give it the name. For example, calcul area. We said, suppose we wanted to do a calculation of the generic area of a triangle. So in this case, we actually don't get any proposal from the moment. I write, for example, a triangle area. So you can see that ST is not proposing that we declare that we are doing to define these as labels. Oh well, we'll do it right after. So our area, our output result will be base multiplicate 8 divided by 2. So at this point, you see they are underlined in red because they are not recognized, they have not yet been declared. So let's go and do it. So at this point, at this point, I will copy and paste hours since I've already defined some names. Here it is. So the air will be our label. The data type we said we will work with the float class var output. So let's do this. So we define var input and var output, and I same the same things for base for triangle base. But so also in this case I in the class say var input, and at the end the our var output to have the result. But no, sorry, I'll tell triangle 8 also var input causes a date, and the area triangle is our var output. Here this is our now we add our function. So potentially this our function calculating the area of triangle and returning to our unique, in this case, program block. We could use our area calculation function. Let's associate the triangle-based inputs. So we define an input label for our program block. We are back in FBD. He proposed us at this input at this point. In short, it proposed the automatic declaration of the triangle base as a variable, a type of float data, because it already recognized that it wants to input a type of float data. Likewise, triangle 81. Here we will bring instead the result of the function and copy it out to our further program label error triangle 1. Give okay. In fact, now we always define. Okay, so give me a. Oh, okay. We will see. We will see when we go to compile and download the project if this function works as we expected. Function blocks are called from program blocks or other functions. So you could also encapsulate a function block inside another function block, so to make even more structured the programming, let's say. In the definition of a function block, but without defining input variables and output variables, the function block can therefore store, unlike the function, the value of a variable. For this reason, the same value of the inputs does not necessarily correspond to the same value of the outputs. The use of an FB in a program implies the definition of an instance, which follows the same rules as labels. In the most generic case possible, where you have to interface in a program logic with n electrical axes of the same type, how to say you can think of encapsulating, therefore building a program logic, therefore managing that the electrical axis are ready to manage all the electrical axis present on our machine. The logic is written only once a FB is created. N instances will be created and added to the project, as many as the axes we would like. Therefore, managing the idea of the the function block, sorry, is to then create instances, then write the program, write the code only once, and reuse it n times, for example, an automatic. Each with its own life, which will each life its own life. Therefore, as in the example we are giving, A, yes, only will perhaps be in speed. The other will be in homing. The other will be in error, but the function block is unique and will differ from each other for the instances, for the concept of instances. So there will be an instance for axis 1 of that function, an instance 2 for another axis of the same function block, and so on. How do you create a function block? Similarly, at new data, you select function block, you give a name, and you choose the programming language. In this case, the example is related to the fact that you want to create a pattern. So you want to create, you go to represent one cylinder and actuator, and for this they want arms be uniquely defined. Here the logic is, for example, if either the forward sensor backwards at the same time for me is an alarm condition, or else I have given the forward command and I don't detect the forward sensor within a certain time. This is another alarm condition, I said, so maybe here in this case I write this FB only once. Okay, I insert it into the project, and then maybe I go to recall it. I have to interface with 3 cylinders. I go to instantiate it and have 3 instances created for 3 cylinders present in the car, in the machine. In this case, therefore, we are going to create a function block. We can call it actuator alarm FB. We write in FBD. So after now we can name this function block FBD LD, and now we can press OK. So now we come here, we said, so our logic has the forward sensor and backward sensor at the same time. This for us, this is for us an alarm, sorry, is an alarm condition. So sensor forward will be this input variable, therefore it is an input variable. I will link my addressing to the sensor in this case. The concept that for us in this context must be an input variable, therefore local to the FB which we are creating, var input and bit. Okay. Same goes for the other sensor, var input. Okay, but instead we determine the Boolean alarm label. It will be a var output. So in fact, var output, okay. The other condition, we say the forward command. Forward command, we don't identify, we don't detect the forward sensor within a certain time. So in a certain time here, in the case we use in the system with a ton, then a system FB. Boolean, okay. Let's leave this generic, could change the name, but then yes, here the with uncertain time, in this case we use system ton, therefore a system FB. In fact, Boolean, okay, let's leave this generic. We could change the name of this one, of this FB data. Is an internal variable. However, at the input, it will want a timer. So a timer. So if we place our service, here we place our cell, let's say, near the entries to the PT, near the entries in PT tells us that it wants an object of type time. We also call it for this reason. For us, it will be an entries because someone from outside who will use the FB will define what is the maximum time for the detection of this alarm on this particular condition. So we call it timer. And factor, we now define an input variable of type time, and in the ET, this output, the elapsed time, is determined. We are interested in knowing when the passage of this time under these enabling conditions. So is therefore valued the output, therefore which for us means alarm, therefore within the time it is not within this time, it has not been identified, the sensor forward has been recognized in this case. Equally command back. So now we can we can select, we will put the capital letter command back, so it will be a variable input, okay, defined, and sensor and our sensor back. So we can select it, okay, and now we adjust our structure, our program. Okay, this is the logic of our FB. Let's go to the automatic part in the main program body. Here now we can recall an instance of this FB. We have to go and create this run. So in the meantime, let's say our FB alarm actuator. Here, like a function, it asks us what the level is. So we have to identify an instance that goes here. We are referring to what for us is, for example, actuator 1 of the N present on our machine, which we can clearly determine, associate this logic. So we press OK. So here on the left side, we will find our inputs. On the right side, our outputs. In this case, in a FB built by us user, we can double click to access the code. In fact, now here we are going to put now here we are going to put of our further labels. Actually, we quickly exploit system devices. So for example, M2, M3, M4, and here M5, and on the timer we place our label timer actuator 1, for example. So a type of time, internal variable, okay. We report the alarm on M10. Okay. Okay, compiling the code. Once part of the program has been written, I can proceed with the compiling it to verify that no errors have been made, and therefore be able to proceed with the download. Different convert option. Let's say we'll appear different convert option, then let's say will appear here at the top, just like convert, and I follow the compilation of only the code of the edited labels from the last compilation performed. Certainly less invasive than a rebuild all, which will take more time and compiles the entire program and the project labels. There is also the possibility of making online program changes, and if no errors are detected, the changes are made online on the CPU, even if they are running, therefore without going back to the stop state. Obviously, you are connected if you are connected with the PLC. If errors are detected, double clicking on the error item takes you back to the affected part of the code. So let's try to compile. Here's how I told you in everything that it's red means that convert hasn't been compiled. Now you could actually do a convert or a rebuild all if the convert entry isn't found. Tool option, then execute the position convert, online program change, execute online program change in converting, let's say no. Okay, now let's find the convert. Well, there is an error. In fact, we after the is conclude, in fact, we can see an error. Then the program conversion, please connect to element. Come on, let's double click. It brings us back to the error. We left this pending. It goes. We completed our label. Maybe in this case, we define it as a global. So, okay, we perform another convert, and now and again there is an error. Here too we want an enable, so we write true. So let's write okay, and now we perform again convert, and now there aren't errors. So we have filled in. Now there are parts have not gone away, then the project is ready to be downloaded. Okay, connection PLC configuration. In the connection destination menu, it is possible to create different types of connection with PLC, which can be named as desired. The connection present in current connection is the one in use. To change it, drag and drop the connection you want to use or select using the auto on the right. Let's see what that means. So what we are talking about. So far we have worked on the navigation part. Let's move to connection destination. So what are we talking? So we move to connection destination. Okay, here we find the two items: the current and the all the connection. You can, for example, redefine. Then I don't know. I create one for a USB connection, and I create one an Ethernet connection. So on the currently in use by the system, which will then try, let's say, useful the setting to which the system will then refer, and those of currents. For example, now I'm going to see to work on a communication on my Ethernet connection. Good. Let's define it. Let's define by looking at the slide for a moment. Looking back for a moment at the slides, of which in fact, well, let's get into this part of the configuration. As far as Ethernet is concerned, let's say on a direct connection, there are two methods: Ethernet, direction port, or connection via hub. In practice, In the first, in this direct connection, it isn't possible to set the address. It is not necessary to set the IP address of your network card. Network in the same sector, PLC types, we can continue wording in DHCP. Part of connection via hub, instead we can go and point the therefore put our PC, our network card in the same IP class as our PLC. At that point we can connect to the PLC through IP. In my case, therefore, I choose to work with communicate with an Ethernet connection. I double click. I go to correctly set the communication network setting on the PC side. So I'm on an Ethernet board. I'm going to specify what my network card is. Okay, PLC side. Okay, we will have different option. So for example, we can also do a pass-through via through GOT. In our case, PC module. Okay, we return to the double-click screen seen in the presentation. In my case, I remain in DHCP Ethernet port connection. Okay, I can do off and select OK. Other station settings, select no specification. At this point, let's try to perform a connection test. Okay, success connection with R04. I'm going to press OK to save the settings. Okay, the factory IP address of the PLC is 192.168.3.39. Connection test, therefore, is what we have just performed. Until the connection test has been verified, we will not be able to download the project. Downloading the project, once the connection is established, you can download the project. It is essential to reset the CPU when modifying its parameters. Effective in effect for reset, therefore we mean the position through spring return that occurs on the PLC selector. We will also see that we will see that it is also possible to do a remote reset. So at this point, therefore, to download our project on the and write to the PLC, fix and okay, so no, okay, so fix and ok, parameter exist, quindi parameter facciamo online and write again to the PLC. Okay, parameter plus program, so let's select parameter plus program. It will select everything that is indispensable at this moment. It is necessary, then our FB and function files will also come. Once we have our program, our global label container, the system CPU parameter, and so on. Here there is important information on what concerns program's memory. So in the second part of the course, for example, we focus on the discussion of program devices. Label here, however, we find the memory specifically used to contain the program. So the more program we write, the more we will occupy. In this case of an R04, 160 kbytes, as we said. The 160 kbytes is the equivalent of 40 key steps. So there is 1 times 4. So now executive, so it goes to execute the project writing of the PLC. Okay. here is first writing. We have changed some parameters. So what the slide told us is to proceed with the CPU reset anyway. Now at the reset, could I go to the physical selector, but alternatively perform a reset of the PLC from remote. We will enable the more parameter operation related setting. Remote reset setting, then remote reset disable. We will enable our remote reset. This would mean that we could then go through online remote operation to perform a reset of the PLC. In this case, if for example we try to do it, it tell us which is not possible. We should enable this option. Okay, in my case I'm going to quickly perform a reset, the physical selector. Okay. So in fact, what I said before, we should enable this option. So I'm going to execute quickly reset the physical selector. And so with the return to no reset string, once the LED have turned it off, the selector returns to a stable position stop. In stop, our program, clearly even in error condition, our programs are not in the main state. So now we are in state of stop. Let's see what the next topics are. Here it's clearly the same thing. We just performed a write, we could do a read and then a project upload. Here too, once a connection with the PLC has been established, it's possible to automatically detect the configuration of the module physically present on the rack. In practice, with this online option, read module configuration, for example, if we were already faced with one hardware perhaps with more modules rather than going and building, we could put the hardware configuration by hand through this operation. Okay, let's see what monitor mode means. Let's monitor and then let's talk about debugging. Let's monitor our program. In the meantime, I close all the windows with Tidy Up close on Windows. Let's open our automatic, which is in fact the only container with the program with the code to go into monitor mode. Then go and see what actually happens to our programs. To our program, let's select this little start monitoring icon. All Windows or start monitoring would only refer to the open Windows. We select all Windows, in this case little changes. Here we begin to see what is what the flow of our information is. So there's 1 and zeros. This contact is open, our data is initialized to 0. As mentioned, at this moment the CPU which is placed in the stop state through the physical selector, we can say that our CPU is stopped, so our program will certainly not be cycling. Let's ring the mention, then I move the selector to run. Okay, change here from on this little icon changes the state, so here our selector is run. Here instead we have an indication of the scan time, so the current, the maximum and the minimum. So when we're talking about scanning the PLC right now, we are running at 0.1 millisecond. So we entered in the world of monitors. The cross-reference returns the list of labeled device addresses searched for with various additional information. You can cross-reference for entire project only for program block. In fact, this is a tool that can be useful for searching for all the labels or instruction or contacts or strings within our program. Then with the cross reference, for example, we will do file replace, cross reference, or do throw control. All device labels and the project, we may change the settings. Let's go, for example, to select, for example, generic memory. Okay, now I'm writing. Uh, the system is then identifies through cross-reference that there is one label called generic memory used, OL in contact format, and tell us where it is, in particular in the program file and the automatic program block. So this can be useful to research and understand where our memories, our labels are used within the various project programs. Okay. For example, we have exploited M2, M3, M2, M4, and M10 device list. Always do file replace, device list, or control. In this case, for example, we want to see if this memory, this user device is already free, and I have opted use M10. Okay, like clearly we type M10, then he offers us the whole list and all the status. Here M10 counts them 1, he counts 1, for me 2, M4, M3, M5. So this can be a way to understand the moment in which I'm restoring and programming through user device if they have already been allocated and used. The other one, another useful debugging tool is the watch table. These are tables of variables that can be composed by the user, through which it is possible to monitor and modify the state of the variables. So we will populate our watches with the object of interest, right-click on one of the variables in the table, then start watching, so we can always like say stop or restart the watch on these tables. Make sure you are aware of the variables possibility of selecting the display format individually for the devices. But in fact, this is a watch table, so we are in monitor. In the meantime, we could see them from here, then as view, docking windows or watch 1, 2, 3, 4. We said that there are the most 4, or I could, for example, in the case of watch 1, access it via the tab below. Like you said, we can move these windows around as we want, but right now we're keeping it here. What can I go do? So I can go, for example, to popular my entry with the label with data of interest, in this case triangle base, register to watch, windows equal to 1, and sure we also add the height of the triangle with the same procedure. For M2, M3 and M4, but in general for data, for Boolean data, we could go directly to shift send also directly on the editor. So without the bring the watching to change the state of these variables. Let's bring the two of us. Okay, so we are going to populate the entry with this variable that we want at this moment, on which we say is on which our attention. So I could do a shift enter, change the state of the bit from on from off to on and or on to off. Therefore, directly from the editor, or once I brought them, that I brought them here in a Boolean data. A Boolean data brought to the watch table? Could I use this on-off button to change the status, or could I come through double click here to change the state of the current value? It's general, it is worth saying that it's a scratch, but program logic always win. That is mean if here we, for example, try to change the state of an output, this output, however, from the moment it is active in quote our program could be overwritten, so it is in the execution code PLC which wins over our forcing. A trick perhaps regarding the input output signals, so in particular the outputs you can bring the particle so it stops state, and that points perhaps try in the debugging phase of the application. We are talking about verifying that they are electrically connected correctly, ensure that our outputs brought to an active logical state by the software actually give R as it were driven and controlling at the point right. So we say the little trick can be to path the PLC to stop and then work on, in this case, Y0, Y1 on our output devices in electrical shocks in stop. So we will then go and change the state of these variables. So in fact, so start watching, and now we can stop watching, or we can restart it, then right click start watch. We can also right click in the header of the watch table. We could also select other objects of individualization interest. So for example, signal clearly on Y0 we find in Y0 because they are user devices on our labels. Not we have associated with our labels, we have not associated any device assigned, so clearly they are in this case empty. Now let's return in the we here now also bring the actuator timer. Perhaps we determine here in this case 2 seconds. So now I set the time, in fact 2 seconds, and okay, so let's try to go and in fact now command forward, and how not how to say don't pull up the M2 for the forward sensor, and therefore after 2 seconds we will have to detect the alarm. So in this case I place myself on M4 command forward shift of my and change the state of command forward. Okay, we have our alarm. We are making some bugs on this FB. What we said to ourselves is that with the CPU in the state of run, the code always has priority over forcing through watch table. This is the part of recording the variables of the watch that we have just performed. Device buffer memory match monitor, the ability to monitor adjacent devices in a single window. Okay, in fact, from the moment in our program, therefore, we have to carry out debug, or in any case, a display of the user devices. Therefore, not of labels, we can resort to this table present in the online monitor system device buffer memory. Okay, here, for example, I'm interested in one of two, of three, of four, of five, and so on. Maybe I ask to view starting from one, and I see all the user devices. In this case of type of, I see them on the monitor already in this tabular form, so without having to add them one by one in our table entry. So here of 1 has a value 45. Why? Because okay, we transferred this value 45 to 1 with this move. For completeness, this monitor can also be useful where you need to go, such as accessing, viewing, or writing. But let's stop and let's stop with the smartphone. So here we're going to type the address and the slot, therefore, to unit to which the expanding memory is refers precisely to visualize our memory. Therefore, U/G, for example, 1000, referring precisely to the buffer memory 1000 of the intelligent way Chu, and also for this we could use this point, this visualization debug tool. Okay, in the same way as cross-reference, we can find files within the program. Okay, as far as PLC diagnostic are concerned, possibility of monitoring the PLC status directly from the toolbar with further indications on cycle times. We've already talked about this troubleshooting tool integrated into the GXWorks tree to view any errors present in the history. Here, for example, now we access this screen here. For example, the diagnostic of the CPU of an R08 is telling us a bit about what the error code is. The current state of the CPU is a description of the current error. Therefore, what the causes may be, what the corrective action may be, and the point at which it was identified. The error can therefore be even greater. So, to speak, I deal with software errors mainly with jump errors, and the GX takes us back to the exact point where the error is identified. The section, in this case, diagnostic system, monitors our diagnostic CPU modules. Okay, here we get a little bit of our rack right now. So we're working with R61P and R04 at this address. We are in monitoring. We could stop the monitoring. We are told that the state precisely the run of the PLC is trying to stop the PLC. Okay, the state is replicated in this case of the CPU, which is stopped because I am moving the selector from run to stop. I report the run to the CPU. Clearly, the run selector, an essential condition for the program to run, but it isn't said that the selector is clearly placed in a state of run, the physical selector. But I know from could with the GXWorks tree, so to the operation we saw before. So for example, to do a reset, we could still put the PLC to stop. The PLC itself goes into a different condition from the run. For examples, deals with an error. So clearly, I repeat to be able to run, but it is not the only condition. It is a necessary but not sufficient condition for us to say that our programs are running. In production information list, we find other information, in particular what the firmware version is. So it may be important to identify the firmware version of your PLC. As mentioned, the update can also be done via through SD card. Okay, double click on the PLC module, and let's go to the module diagnostic here again. the name product information module. In this case, there are neither moderate, not mirror, not major error. So in this case, I mean everything is okay. In case it wasn't, we will return to a situation of this type, therefore, in which the error number appears with precisely one error code and information also relating to the severity, in quotation marks, of the error. It particularly for majors is if an error for majors is an error which therefore like an error, let's say hardware or memory failure, will therefore certainly bring the PLC to stop. A moderate error will also bring the PLC to stop. A minor error, however, as can be one flaw on a communication, the CPU could continue to operate, so we couldn't go to sleep. Simulator. Then from the debug menu, it's possible to start the simulator to test the PLC logic. So far we have worked by interfacing with a real PLC. Okay, and to start the simulator, go to the home page. So in this case, I disengage from monitoring mode. I'm going to work with a simulated PLC, start simulation. Okay, here I'm going to work with virtualization, so I can perform all the operations, particularly on the switch, then putting in the runs. Okay, so put run. Okay, the P-run LED is indicative of whether the programs are running or not. When the green LED is on P-run, it means that our programs are running. As mentioned, it isn't certainly that the stall of the status of the physical run selector necessarily corresponds to run, therefore to a program run. At this point, in a completely similar way, I can go and launch the simulator referring to my virtualized PLC. So further on, apart from that of this pop-up, let's see if let's see if we are working correctly. For example, triangle base. So launch the library. Okay, so we can launch the library. So we are still running on our simulator, and here we find all the information. And in this case, I was referring to the scan time of the simulated PLC. Okay, and now I can finish with the Emmanuel viewer. And as I said, it's a help and it's an help, an offline help. So now I have opened my Emmanuel viewer, and let's go back to the one on, let's say, the previous screen above. However, we have the wall section of the manuals as mentioned for IQ-R, but not only. In particular for IQ-R divided by types. For example, if we are interested in something related to our CPU, we could go to R04 CPU. Are the manuals related to the CPU given here? For example, in the second part of the course, we had worked on hardware configuration with a PSN master. We will go to network module, okay? um, TSN, let's find our module. In this case, below in the container, in this case, below in the content part, we find two manuals, startup and application, and here above all the application part. We find information for example relating to what are the module label signals available for this intelligent module, to what are the point signal that the module brings with it, a listing with the complete registration of all the buffer memories of this intelligent module, and so on. This is clearly an example of what it can be like to navigate the hardcore of the manner of the order. Yes, absolutely recommended keeping this tool updated. They run then when there is an internet connection, and download the new document. At this point, we could look for all the documents not present in our manual and could integrate them, the missing ones, and update those already present. I conclude with this. Thank you for listening, and wish you a good day.